Hello and welcome to our next video. This is a lesson about prelude to 1.2. Section 1.2 in our book asks us to do a lot of graphing stuff, but without a good background knowledge of how to do some of this stuff by hand, it becomes a little bit ridiculous. So here it is. We're going to be graphing a linear, absolute value, quadratic, square root, cubic, and circles equations by hand. Well, starting out with linear, of course we've got an equation such as this, y equals 3x plus 2. That's our standard mx plus b sort of setup. And so of course we look at the 2 first of all, plot that as our y-intercept or our b value. And then of course thinking that as a 3 over 1, if you like to think of it that way, whatever works for you. Count up 3 over 1, make your next point, up 3 over 1, and you can do that all day. And additionally, of course, if you'd like to go in the other direction, you just kind of reverse both moves. So instead of up 3, right 1, you just go down 3, left 1, and make a dot, down 3, left 1, boom, and then from there, of course, you can just connect all the dots. I do want to see arrows on your graphs, so please do that. Of course, indicating that it does go on to infinity in either direction, but there you go. So now for the next types of graphs, starting with absolute value, I'd like to start talking about the graph completely unchanged by any sort of thing, because I'd like to talk about the changes as a whole later. But let's look at f of x equals absolute value of x. Well, of course, you could do an xy chart for that, but basically, hopefully the absolute value, you know that that's going to be basically a V shape, but worst comes to worst. Of course, if we plug in 0 for x, we get 0 for y, so we're starting at the origin. Okay, and if I plug in 1 for x, I also get 1 for y because the absolute value of 1. If I plug in 2 for x, I get 2 for y for the same reason, and I can keep doing that all day. If I start plugging in negative x values, plug in negative 1 for x, but of course I take the absolute value, so that gives me a positive 1, negative 2 gives me positive 2, negative 3 gives me positive 3, etc. And there we go. Again, that basic pattern will continue on forever. So I end up with a nice straight V shape. Notice I have a slope of 1 on either side, technically negative 1 on the left, positive 1 on the right. But that's our absolute value graph. I like to say absolute value very hard because, of course, the V in absolute value and the V shape of the graph kind of go together. Hopefully that stupid memory trick right there can help you. Our next unaltered graph that I'd like to talk about is our quadratics. And the quadratic, of course, better known as a parabola, looking at an x squared. Similar argument to the absolute value that we just did. If we start plugging in 0, we get 0. Because 0 squared is 0. If you plug in 1, you get 1 again. It almost looks like we're going to start doing an absolute value graph. But if I plug in 2, of course 2 squared is 4. We get 1, 2, 3, 4. And then if I plug in 3, I definitely don't get 3 again. I get 9. So that's 4 right there. 5, 6, 7, 8, 9. Alright. Good thing is about squaring is if you square a negative, you get a positive. So we do have this symmetry sort of thing going on here. So that if I do negative 1, I get positive 1. Negative 2 gives me a positive 4, and then negative 3 gives me a positive 9. We can, of course, extend that from 4 up to 16, whatever, but we quickly run out of room. Okay, one thing about the quadratics I would like to talk about real quick, and you can think of the XY chart that I kind of talked through as I graphed that. Notice that the 0 gave us 0, and either plus or minus 1 gave us a 1, and then plus or minus 2 gave us a 4, and then plus or minus 3 gave us a 9, and we could continue if we had a large enough graph. Plus or minus 4 gave us 16, and we could continue that basically as long as we wanted to. Granted, in many cases it's not really necessary to graph that much, but there you are. Alright, the thing that I really want to stress about this is I'm going to use this as a graphing technique. Most textbooks, after you find the vertex of a parabola, want you to plug in several points in either side of the vertex and spend several minutes calculating y values and things of that nature. But if you kind of take a look at the basic pattern here, from 0 to 1, okay, notice that's an increase of 1 in our y coordinate. As our next step in the x direction goes out to 2, we increase in this step by 3 in the y direction. One more step in the x direction, this time we jump up by 5. And then one more step in the x takes us to a jump of 7 in the y. Next step in the x gives us a step of 9. Now notice these are jumping up by odds. Okay, so a nice little pattern we have. I like to call this 1, 3, 5 graphing. So basically what I could have done instead of talking through this is found my vertex, which is at the origin, and then I just had to go up 1 over 1, up 1 over 1, 2, 3 more, and then up 1 over 1, 2, 3, 4, 5, and that would have given me all the points there instead of going through that XY chart. But regardless, and pretend I actually drew that through the dot, if you do my 1, 3, 5 trick, you actually get the exact same parabola as walking through an XY chart, and my trick goes a lot faster. Just something I recommend you do as we're doing this, and we'll get into it more later, but there it is. And now moving on to graphing square roots. Again, completely unmodified graph, any sort of extra numbers thrown in there, so just taking a look at the bare bones. And before doing the talking through the XY chart, I'd actually like to draw it out here. Alright, so XY. Okay, so, well, 0 is an easy number to plug in for x, and in most cases it's a good one to go with. And if you plug in 0 for x, you do get 0 for y. Square root of 0 is 0. That works. Okay, then I can plug in 1 for x, and square root of 1 is 1. So, again, kind of a pattern forming of some of these graphs we've had. But now I don't want to plug in 2. If I plug in 2 for x, I'm trying to take the square root of 2, and I have to have that memorized or something, and that gets awkward. So I want to, just carefully pick some values for x that work. So basically, I want to take something that can be square rooted, basically perfect squares. So the next number I'm going to pick is going to be a 4, because I can square that nicely down to a 2. Likewise, I would then purposely pick a 9, because I can then square root that and get a 3. And again, we can continue this on as long as we wanted to. 16 gives us a 4, and just like the parabola, we'd end up with 25 and a 5. If you remember about inverses, hopefully you remember this is basically an inverse of a parabola with a little bit of a restriction on there, but let's talk about that in a future lesson. Okay, but basically, if we look at what we've got now, we've got 0, 0 at the origin, we've got my 1, 1, we've got 4, 2, and then I've got 9, 3. Alright, so what I have is actually half of a parabola. Alright, and you might think, well, parabola, that had that 1, 3, 5 thing. I just wish this one had a 1, 3, 5 too. That'd be really cool. Well, good news, it does. Okay, remember it's that inverse, and inverse basically switches characteristics of the x and the y, and that's what we have going on here. The y from the original point to the first point goes up by 1, and then from here we go to up by 3, then we have to jump in the x direction by 5, and then we have to jump again in the x direction by 7, but then that does generate that same pattern just in the x direction now and not in the y. So notice now our horizontal moves are 1, 3, 5, etc., and our vertical moves are just 1 each time. So again, starting at the origin, we go up 1 over 1, up 1 over 3, up 1 over 5, and it generates that same exact graph very quickly without having to work through this sort of XY chart thing, and overall just thinking too hard. Now if we counter ourselves a cubic, okay, we're going to have to worry about is, well, what I think is very similar to a parabola. There's a nice pattern that's going to evolve, and actually before I start putting anything on the graph, let's take a look at that first. So, XY chart here, I'm going to put the 0 for the x in the middle for now, and of course if I take 0 to the third, that still gives me a 0. Plugging in 1 for x, it'd give me a 1 still for y. 2 for x, it'd give me an 8 for y. And then when by the time I put in a 3, I'm going to get 27. And that starts getting really, really big, and it's not going to fit on our graph. So let's start looking at negatives. Negative 1, well, 3 negatives makes a negative as I take negative 1 times negative 1 times negative 1. And get negative 1. If I do the same thing with the negative 2, that guy times itself 3 times gives me a negative 8. And same thing with the 3 up in the positives. By the time I get the number out for the y, it's really too big to fit on any graph that we normally would encounter. So realistically, we're only looking at the 5 kind of points in the middle and ignoring the x values of 3 and negative 3. Alright, so once we've got that, we've got our 0, 0, 1, 1, and then 2, 8, and then the same basic thing, and then negatives. Alright, so to me this thing looks like a barrel of monkeys. Monkey, if you remember those things from playing with them as a kid, if you did that. You know, the monkey's nice red color, came out of a barrel, low on one side, high on the other side, so you could hook them together and make a big long chain. So there you go. And in terms of the pattern, if we switch colors here real fast, okay, the 1, 3, 5-ish pattern from a parabola doesn't exactly exist here, but if you look at the x's increasing by 1 or decreasing by 1, depending which way you go, okay, the y's, the first time increased by 1, but then the second time increased by 7, and then again, unlikely as it may be, if you take it out to the third jump, is 19. Again, I'm kind of ignore that, so realistically, instead of 135 graphing, I think of the cubics as 17 graphing, and as long as you can remember you're supposed to look like some kind of a barrel of monkeys by the time you're done with it. You over 1 up 1, over 1 up 7, and then left 1 down 1, left 1 down 7 more, and you've got yourself a very quick, very accurate graph of the cubic. Alright, if we find ourselves needing to graph a circle, first of all, we should be able to identify that equation by having an x squared plus y squared equals some number squared. Well, obviously it's not that obvious that it's a number squared, but that 16 that I'm using in this one is representative of the radius being squared. So for our purposes, that means for this equation, we're going to have a radius of 4 for our circle. Alright, you probably remember having some other messiness going on over here with the x and the y squareds. Basically, those account for shifting off of the origin, and since none of that exists right now, that we know that our center is going to be the origin. So, as far as a graph goes, I think the best way to do this by hand, without getting ridiculous about accuracy, is to just plot your center, and then take whatever your radius is, and just simply count up, down, left, and right that number of units. So 1, 2, 3, 4, up, and then go down that far, go right that far, and go left that far. Of course, the order you do this in has no bearing on anything, as long as you get those 4 plotted. And then, I know we're not all artists, but Michelangelo could do this perfectly, but since we're not Michelangelo, as long as you can give me something reasonable to a circle. I know most of us will have something that looks fairly eggy, but try to not make a diamond out of it. As long as it's a little bit round, I think I'll be happy with what you've done. So there's our circle. Alright, let's start talking about graphs of transformations. Hoo-wah! We've got ourselves y equals -3, x minus 1 squared plus 5. Okay, now, hopefully immediately you start thinking, okay, well, what's the basic shape of my graph? And the second you see that square right there, hopefully what goes off in your head is, hey, I'm looking at a parabola. Okay, additionally, hopefully what goes off from what I said earlier is, hey, there's a silly 135 pattern with those parabolas. And, kind of saves me some XY chart work and makes things a little easier in my life as a whole. But there it is. Alright, I've also, for this one, chosen like worst case scenario, just so we can talk about everything all at once, as far as the various things, transformations, if you will, that can happen to a graph. Alright, I'd first like to talk about this number right here. Now, hopefully, some of this is review for you, but if you put a number inside where the x is, and with whatever characteristic feature that equation has, like the square for the parabola, or absolute value symbols, or whatever that sort of thing is that makes the equation uniquely a given shape. Alright, that number inside there is going to be a horizontal shift, and what I like to think of it is he's a big fat liar. Okay, because even though it's a -1, I know he's going horizontally, but actually what that's going to send us is to the right one, because he's lying to us. So there he is. Okay, secondly, I've got another sort of addition or subtraction-esque thing, and this guy's on the outside. Well, if you're on the inside, because I just think of silly things just to keep myself from being bored. He's on the inside, he's like an undercover secret agent, and that's why he's going to lie to you a lot. This guy, he's out in the open. If you ever heard the expression about being open and honest, well, there he is. This guy is honest. Okay, so he's going to be a vertical shift, but he's actually going to go up 5. Okay, so for our parabola right here, our vertex is going to be right 1 because he's lying to us. So 1 comma, and he's telling us the truth, that's going to be a 5. So right off the bat, I know I can plot 1, 1, 2, 3, 4, 5 as my vertex. Alright, the other things that are going on in this, and let's change colors just to be fancy. Alright, I've got this negative sign right here. That negative sign is going to basically flip us over vertically. If you want to think of it as a reflection over the x-axis, that's fine. You just have to be careful how you do it, because I just like to think of it as you plot the vertex and then go upside down from the vertex and not an entire flip over the x. I think that gets misleading. So I just like to think of that as flipping upside down. Okay, and then the other thing is that 3, and let's change colors again just to be super fancy. Alright, this 3 right here is going to be a vertical stretch. Now I want to stress that's going to be vertical because that is going to impact us on a couple of the problems later. So that's a vertical stretch. Now where it's going to come into play here with our 1, 3, 5 graphing is that instead of going 1, 3, and 5 as my vertical moves, because of that 3, my 1, 3, 5 graphing, 3 if you think of it as like distributing or magnifying the vertical stretch, whatever works for you, my vertical moves are now going to be 3, 9, and then 15. Now granted, because this 3 times a 5 gave us a 15, that's numbers that's probably not going to fit on our graph, so we're just going to fit exactly as much as we can and just going to deal with whatever happens from there. Okay, now hopefully that made a little bit of sense, but going back to our vertex now, again I'm going to move over 1 because that's what you do with a parabola, but instead of going down 1, I'm going to go down a total of 3 because that's what my purple numbers down here tell me. Over 1, down 1, 2, 3. And then I can go over 1 again, because that's the basic pattern for a parabola, but now I want to try to go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm sitting right about there. And clearly if I go over 1, I don't have room for a 15. So go back up here, and then the nice thing about the symmetry properties of a parabola is really I just have to mirror what I did on this side. So I just kind of go over 1 and I just find the other point and I match up. Good idea to just count just to make sure you didn't mess up or anything, but and then go over 1 more and then head on down to there. And I've got myself 5 points, which is pretty good for being able to draw a fairly accurate graph. So if I connect the dots with any skill whatsoever, and apparently that one was pretty messy, I should be able to draw myself a fairly decent parabola in just a matter of seconds. And there you go. And notice I didn't have to do any crazy XY chart that every math book I've ever seen in my life is going to have you do at that point. Alright, now looking here, again we've got a situation where I'm looking at this equation, and the first thing hopefully you can do is recognize that third power here gives you a cubic, and consequently that 1, 7 barrel of monkeys fun type of graph. So I'm looking for that kind of skinny ass barrel of monkeys, whatever you want to think of it as the shape being. So here we are. Now I've got this 1/2 out in front, and I've also got this +3 out of here. Me personally, I just like to do the shifts first, which is going to always be represented by the adding and subtracting. So this +3, notice he's not on the inside of the cubic symbol. Okay, he's just out on his own right here, so this is going to be the honest guy, and this honest guy is always going to be a vertical move, and so basically that's going to send my graph up 3 from where I normally would be. And my starting point, instead of now being at the origin, it's going to go up 3. Okay, there's this 1/2 we're going to deal with in a minute, but I'm just going to take this guy up 3 to start with, and there's like the middle of my monkey, if you will. Alright, now this 1/2, like purple looked good, let's do that again. Alright, this 1/2, again, is a vertical stretch of 1/2. So if you're vertically stretching by 1/2, it's kind of more of a smash than a stretch, but whatever terminology works good for you is fine with me. But long and the short of it is, I'm going to take the 1/2 times those moves of 1 and 7. Again, you can work in the 19 if you wanted to, but again, by the time we do this plus our starting point, we're going to have 5 points, and I'm okay with that. So I'm going to have a 1/2, and then of course 1/2 times 7. And then here's one of those times where I think mixed numbers actually kind of come in handy. So this would be a 3.5. Of course, if you want to go with 3.5 or a 7/2, if that works for you, then I'm great with that. But basically now these two are our vertical moves as we move away from our starting point, which is our red dot here. So here we go. Alright, now again, we're normally high on the right and low on the left with our monkey, and there's nothing that's changed us so far as that goes. So starting at this origin, I'm going to go up 1, up 1/2. So just kind of split the difference between these two lines, and then I'm going to go over 1 more and up 3.5. So I like to do the half first, just to get me to a grid line, and then I just need to go 1, 2, 3 more. And of course we got this kind of symmetry property. Going left 1, but we do have to go down because we're not making a parabola, we're making a monkey. And then over 1 more, down 1/2, and then down 1, 2, 3 more. Make your other dot. And really we might have been able to fit in that 19 times 1/2, but again, I think once you got 5 points, you're probably in pretty good shape. So let's kind of take our squiggle through there. And then again, in a few seconds by hand, you've got yourself a fairly accurate graph of the cubic function. Okay, now if we take a look at what we have here, we've got our square root. again with some other decorations on there that are going to alter the graph, but the basic idea is we got this square root. So again, what we have, and I don't want to put this on the graph itself, but before we would do anything else, hopefully a little picture in your mind is that half sideways parabola doing something like that. Alright, so now we just have to figure out how these various numbers and the negative sign here are going to alter that. And again, I like to handle my shifts first, so this +1 right here, again, he's not underneath the symbol, so he is being open and honest, so he's going to send us up 1. Alright, so again, instead of the origin being our starting point, as per usual, we're going to start 1 above that. Alright, then from there, I've got this 2, which we've talked about the vertical shifting before, and this one's a little bit tricky because we have that 1, 3, 5 pattern going sideways here. And what a lot of people stop thinking about is that the vertical moves in between the 1, 3, 5 that go sideways are all 1s. So basically, this 2 multiplies by each of those 1s, and well, 2 times 1, I hopefully I don't have to write that out 3 different times, but so we'd go up 2 over 1, up 2 over 3, and then up 2 over 5. And that would be our basic pattern. So this is our vertical moves, and that's going to be in between the 1, 3, and 5. Okay, that does tend to mess people up because now you're thinking 1, 3, 5 for parabolas going up, but now for the square roots it's 1, 3, and 5 sideways with a jump of 2 in the middle instead of the jump of 1 that we're used to. Okay, now that negative sign on the inside, well, that one is just a big, hairy, nasty sort of thing to have to deal with. Okay, and most of the other functions, because of basically how they get written and various other factors that we don't need to get into right now, don't ever have to worry about that. But this one with the square roots, it does. Because notice our graph normally just goes to the right. Well, what if you wanted to send one on the left? Well, then that's how you accomplish it. You put a negative on side with the x. So basically what that is going to do for us is going to reflect this guy to the left. So basically you got to take everything you own and put it in that box, take it to the left. So here we go. Let's get back to a nice normal color for our graph. We've got our up 1 shift taken care of. My vertical moves are going to be 1, 3, and 5, but now instead of going off to the right, I'm going to be going off to the left. So up 2 over 1, up 2 over 1, 2, 3, and up 2 over 1, 2, 3, 4, and 5. Okay, so again, playing compare and contrast between what we had before and what we have now. He's shifted up 1, he rises vertically much faster, in fact twice as fast, and he takes off going to the left instead of to the right. And that's how we can handle a square root function with all that various decoration on it. Alright, for our next example, we're looking at a function here. It could be an equation, we're going to call it a function just because of the notation, but here we go. And again, characteristically the sort of symbols that make this guy what it is again we see this absolute value, absolute value symbols. So I have to start thinking to myself, hey, what's this graph going to look like? And you know, just something tells me that it might be like a V shape. And so again, we just have to think about where our starting point was going to be, our vertex, if you will, in this case. So instead of the origin, again, we've got this +4, but notice he's on the inside now. So now he's our undercover secret agent, and he's lying to us. So even though he's telling us, at least visually, hey, I should go right 4, we do got to keep in mind he's lying, so we're actually going to go left 4 for our vertex. And if there was another number out here, that would shift us vertically, but there's not. So here we are, 1, 2, 3, 4 to the left. And there's our vertex. Okay. Again, those numbers out there are going to mean a few things for us. And that negative sign, that one's really critical because that's going to flip us upside down. And then, okay, one thing that's a little bit nasty about this is we have a fraction. Okay, the nice thing about absolute value is whatever that number is basically equates to the slope of both sides of the v. So the slopes are going to be just plus or minus 2/3. Admittedly, I don't even think about that plus or minus, I just think about 2/3, and I think about going 2/3 up one way and 2/3 up the other way to make a v, but in this case actually it'll be down. So really from here, I know I'm going to be flipped over, and my slopes are going to be 2/3, so rise over run. Rise is 2, and my run is 1, 2, 3, and I'll do that in one direction, and 2, 1, 2, 3. And again, I can do that all day, but again, once I've gotten 5 points, I think that does a pretty good job of indicating what your graph is going to look like. Okay, get to the edge there. Well, let's just keep this purple, because that's my daughter's favorite color. So we'll go that way. And again, pretend that's straight. And there's our absolute value graph in just a matter of seconds. Alright, so now we're looking at it again. This equation looks a little bit unique. And again, hopefully not too unique. As soon as you see the square on both the x and the y, that should, again, hopefully let you know that you're dealing with a circle. So, again, the good thing about the circle now is, well, it's a little bit different than what we talked about before because there's nobody out in the open. You know, again, we've got our x squared plus y squared equals radius squared. So, you know, my radius is going to be the square root of 10. And really, for the purpose of drawing things by hand, I'm not going to make you try to calculate that. So, you know, well, square root of 9 would be 3, and so 10 square rooted is going to be 3 point something fairly small. So let's just estimate a 3.1, maybe a 3.2, but, you know, I think as long as you just go just a hair behind 3, we should be in good shape. Okay, but what we need to do from there is consider where our center is going to be, because we're not at the origin anymore. And so, again, notice these guys are both on the inside. So basically, to me, what that means is they're both liars. So the x direction is getting shifted, well, it looks like a +2, but it's actually going to be left 2. So as far as center goes, okay, going to be -2. And then again, the y right here, he's lying to you again because he's on the inside. So instead of going down 5, he's actually going up 5. So it puts our center at -2, 5, and our radius at, yeah, about 3.1. So 1, 2, 1, 2, 3, 4, 5 gives us our center. And then again, just go up 1, 2, 3, and just a smidge. And 1, 2, 3, just a hair past that. 1, 2, 3, etc. And then again, just do your best, circle through those points. If it's a little eggy, that's fine. If it's a little diamondy, you know, that's fine. But, you know, just do your best. And there's our circle. Now, there may be times, especially with parabolas, and with that square, you got a parabola, that the transformations aren't obvious. Okay, well, from what I've seen out of some of you guys, if you got the algebraic skill to turn the equation I gave you up here, f of x equals etc., into 2 quantity x plus 3 quantity squared minus 5, then more power to you. Feel free, use those techniques, whatever, turn into that. But just as a reminder for one other thing that, you know, depending on the numbers, might be a little easier to work with, is if we just, you know, thinking of kind of quadratic formula-esque a, b, and c here, if you just think of a little short formula, x equals -b over 2a, that'll give us the x-coordinate of the vertex. And so basically for us, it's going to be -12 over 2 times coincidentally a 2. So really -12 over 4 gives us a -3. And then from there, you know, make the room smell good. All you have to do is plug in the -3 into the original equation, and that'll give us the y. And just for the sake of, you know, saving us a little bit of time and effort here, instead of me talking through all those calculations, I trust that you can run through those and eventually get to -5. Okay, so my vertex is going to be -3, -5. 1, 2, 3, 1, 2, 3, 4, 5. Okay, which kind of I did cheat a little bit and knew that ahead of time, but notice that liar -3 and then the open and honest guy -5 would put us there as well. Okay, then the question is, well, do I have 1, 3, 5 or do I have something different? Well, the good news is that same number that's in front of the quantity squared just ends up being the number that's in front of the x squared by itself. So the 2 is going to magnify our moves of 1, 3, and 5 by 2. So we're going to have 2, 6, and 10 as our vertical moves. Okay, again, a 10 may not fit on the graph after you've done the 2 and the 6, but so if it doesn't, it doesn't. So here's our vertex. So over 1 up 2, and over 1 more, 1, 2, 3, 4, 5, 6, puts us there. And just because I know this grid only goes 10, since I'm a little bit into here, I know I'm not going to quite fit on the graph, so I'll come back to my vertex again. Over 1 up 2, over 1 up 6, and again I'm just going to cheat and line myself up with this dot I already made, and I'm confident enough that I counted 6 right the first time. And then again I'll just draw my best parabola through all those points, and that's fairly accurate, and that's how that guy can play out. either again by using this sort of formula work, or again if you prefer completing the square on the original equation or any of that, I'm not going to falter one way or another. Whatever works best for you is fine with me.